SolidWorks Simulation Lecture 12, Dynamic Loading Problem. And this is the part that I will use. There's a slender rod, 10 by 10, with a length of 800, and there's a hammer head, 50 by 50 by 50. So for the preparation step, I need to load the software. Here. Load the toolbar. Here. And in the toolbar, I'll open a study, a linear dynamic study with model time history option. For the material, I will copy the material library onto and paste onto the customized material, and I'll change the material property of 1020 mild steel into a Young's modulus of 3 times 10 to the 11 and Poisson ratio of 0.3, and also I'll change the damping ratio into 0.05. Mesh. Hide the mesh. Boundary condition. The bottom surface is fixed. Loading. I'll define an impact load. So this would be surface of loading, and the direction is okay. So I'll edit the impact loading time variation curve. And at the time 0, the loading is 10 Newton. At the time 0.05, the force is 10 Newton. At the time 0.06, the force dropped to 0. In the time of 1 second, the force is 0. So this is an impact load. At time of 0 to 0.05 seconds, the load is 10 Newton, and the load dropped to 0 afterwards. So this is the first 4 steps. Before we run the procedure, we'll change the properties. We'll select the auto solver selection, and for the number of frequency, natural frequency, we'll choose the default 15 frequencies to calculate. And you can see from here that in SolidWorks simulation, only model superposition procedure is used. There's no direct integration method for solving dynamic problems. So we'll go ahead and define the time step. The ending time will be 1 second, and the time step will be 0.005. So there will be 200 steps in 1 second, and 15 natural frequencies to solve, and use automatic solver. So now we'll proceed with the solution phase. And there are 200 sub-steps to calculate, so it takes a little bit of time to finish. And since it is not very long time, so we'll wait a bit. So this is the result, and I'll see the displacement and show the animation. So after the impact loading, the hammer vibrates back and forth, and I'll probe for the numerical values at this time, at this spot, and show the time curve for the displacement of the point. So you can see here that the magnitude of the displacement does not change because we didn't impose any damping on it. So the displacement will not reduce with time. So we will define a damping here. You can choose the material damping because we have entered damping ratio on the material. You can also define a damping ratio on the frequencies, on the mode shape. And from first mode to the 15th mode, the damping ratio will be 0.05. And now we can solve for the problem. And this time there is a damping ratio. So the displacement of that spot will be decreased with time. So we can compare both cases where damping is presented or not. And we can probe the displacement at the same spot again. At the same spot here, and draw the time curve. And you can see here that the displacement decreases with time, right? Because the presence of damping in the structure. So in this lecture we talk about a dynamic loading or impact loading problem, and we talk about whether damping exists or not. It will affect the displacement of the structure with time.